Hi. Good morning, good afternoon, good evening, everybody. My name is Neeraj Kumar. I'm lead Azure architect, and I have 15 plus years of experience. Out of that, I spent some 14 years in infrastructure space. I'm also a Microsoft certified trainer. Um, I'm also certified on Azure, so I have achieved MCAC certification on Azure as well as MCSA. I'm also certified on Office 365. Today, we are going to talk about Azure Container Services in Azure Talk. Many of you have attended this session in past. On Azure Talk, we have got multiple topics. And Azure Talk is a session, is an weekly hourly session where I cover different topics on Azure. And we have covered Azure IAM and networking in past, and in the same series we are going to talk about Azure Container Services, the container technology which Microsoft brings in, in collaboration with Docker. So today, the session will be in and around totally focused on Azure Container Services. We will not really get into the Docker because Docker itself is a big topic and it can take more than 5 sessions to cover. So we will we will be focused on container services offering within Azure, and obviously that offering leverages Docker in the background, but will not go deeper into Docker, but rather than, we will keep our focus on Azure Container Services. So I will straight away get into the agenda. What are we going to cover today? So the agenda topic that we have is, we'll talk about what is container and how it is different, how it is uniquely positioned, against virtual machine, which is another technology of, virtualization. Container is also a virtualization technology, and VM is also virtualization technology. Then we'll also talk about Azure Container Services, which is an offering from Microsoft, where you can build your own container in Azure and you can run your application inside the container. We'll talk we'll talk about Azure Container Registry. Registry is the place where you will keep your images of your containers. So, Microsoft also offers that offering, so we'll talk about that. Uh, and then, finally, probably if time permits, we'll also talk about Azure Container Instance. Azure Container Instance, which is in public preview. It's not the GS. It's not ready for the prime time. It's only available at this point of time, as a platform. So basically, Azure Container Instance is a platform as a service where you don't build any infrastructure at all, and Microsoft will manage the entire infrastructure for you. So if time permits, we'll get into Azure Container Instance. But overall, our focus will be around Azure Container offering that we are going to talk about. Then finally, we'll have a hands-on demo, and I'll try to demonstrate all these concepts, by building Azure Container and container clusters and orchestrations, behind the scene, and we'll see those in demo. I'll move on to the next slide. So this slide talks about, what's the difference between the VM and containers. So as I said, or the VM is a virtualization technology. VM was like precursor, and in fact, container existed for a longer period of time. And container is not a new technology. It has been around for quite a while. It has been there for 10 plus years. It has been in the Linux world, but it was popularized by Docker. Docker is the company which really revolutionized the way we use container today, and they started offering a container as a service now. So Docker is the precursor. Now we have different players coming to the picture, which helps uh, with your technology. So in case you really think about container is not the Docker property, but Docker is one of the company which is really helping to drive the container adoption in Linux world. So, what's the difference between VM and containers? Virtual machine, as we have hypervisors, and with the hypervisor came in, the hardware virtualization. So basically, now earlier in the old days, you had one a physical server, and that physical server, on which you'll run your applications, or your web servers or your database servers. So then, came in your virtualization. So virtualization is where you started virtualizing, you're abstracting the actual underlying hardware. Now, as an operating system requires CPU, RAM, and hard disk, but whether that would come from physical or that should be presented as virtual, that's what's the beauty of the VM. So VM virtualize the hardware. So basically, it's a hardware virtualization, you can say, and it abstracts the actual hardware from the operating system. So now operating system thinks and acts as if it has exclusive access to CPU and RAM and hard disk. These are some of the hardwares that I'm talking about. There are other hardwares also, but OS thinks that I have exclusive access to it, but the hypervisor layer, which is sitting in between the VM machine and the host server, which is a physical server, that's where it plays the role of the broker, wherein the VM thinks that I have access to physical servers and I have exclusive access to physical servers, where the hypervisor, which is sitting in between, will manage the different VMs and it will give them the same kind of feeling that you have exclusive access to hardware, whereas it is shared. And this was a revolutionary concept. Virtual machine or hypervisor or virtualization introduced something called hardware virtualization. With that, we were able to achieve good amount of physical resource utilization, because earlier we had if let's say I have a database, I would run database on a physical server. If I had a web server, I run on a physical box and web server. If the utilization is not really, it's around 20%, I still end up using one physical box. Whereas when hypervisor came into the picture, now I can have 50 of machines running on the same a physical box. That gave me density. So I can have a couple of machine, 3 virtual machines running on the same physical hardware. So that gave me density. That gave me ability to make use of idle physical resource, which was great. And it really revolutionized the way we were doing IT spend. Now we don't have to build physical servers for different applications. So that really revolutionized the entire IT industry and IT industry spend, and that was the best thing that has happened in IT industry, because now we can have multiple servers running on single physical box with maximum utilization. That was great. So the VM is what offers you the hardware virtualization. That's what happened. That's happened with the hypervisor. And the key parameter is hypervisor. So there are different kind of hypervisors. I will not go details because it's container. You have type 1 and type 2. So this hypervisor is what makes it possible, and it acts as a broker, as a middleman between the operating system, guest operating system or virtual machine, and between the the server, which is a physical infrastructure. All right. The second, the benefit that we got out of VM is it offers kernel mode isolation. So there are 2 kind of modes that usually any application can run. One is called kernel mode, one is called user mode. So any operating system that you have today has 2 mode. One is called kernel mode and user mode. So user mode is where there are different applications run, and it has its own user space. So when I say user space, let's say if I have couple of processes running, all those processes requires its memory, its storage, and those could be exclusively for that process. However, the underlying operating system, or the operating system itself, is a kernel. That space is is only exclusive to your operating system, which is your guest operating system. So now in case of VM, what has happened, earlier we had one physical box, and on top of that we were running this web service and all. So with virtual machine, I could have my kernel mode isolation. So every operating system that you install on top of a VM as a virtual machine, every operating system has a kernel. Now as a part of that kernel is where your system drivers and all operating system related technologies and those keys goes into there. So if you need really kernel mode isolation, which is deep into the operating systems, VM is the way to go. That's much better. So VM offers you kernel mode isolation as opposed to container, which in a container, I'll come to the container later. Then finally, no, VM did started offering us a better physical utilization, which I told you in the resource utilization, because now I can have one server on one server, I can have tens of VMs running, which can make use of the actual physical resource. So that saved a lot of cost, a lot of money, for the IT spend. So moving into the container, so as you say, VM abstracted the hardware, container abstracted the operating system. So now today, if you look at it, if you need an application, every application, irrespective of that you have, you will need a guest operating system. Now this guest operating system bit will have its own resource utilization. So for example, let's say it will consume one CPU, it will consume at least 2 GB of RAM, and let's say 30 GB of hard disk. Now this resource is your, it goes with every application. So now if I have 10 application, for every application I need to build 10 VMs, and these VMs will consume these resources, which is of no use to me. But since without operating system I cannot run my application, so for every application that runs on a VM, I need an operating system. I need to assign the resources to that operating system. That was a challenge. The challenge is why I need to install operating system for every application when I have to use only application. I'm really not bothered about what is underlying the operating system, but you cannot do anything with a VM. In VM, your VM, on top of that you install your application. So VM, the operating system requires its own resource, and then on top of that application has its own resource requirement. So that's where the container comes into the picture. The beauty of container is that it abstracts the operating system for the application running on top of that. So when you install an application, instead of it running it as a part of the dedicated and exclusive operating system, as a guest operating system, containers provides this OS virtualization or OS abstraction. So how it does is you have your servers, physical servers, and then on the physical servers you have your own operating system. So Linux is the best for the container. Container has come from the Linux world. Microsoft Windows 2016 also started supporting containers, but it's not really mature enough as of today. But Microsoft is working with Docker. Docker is the technology behind that, which makes it possible. So you have your physical server. On top of that, you install your operating system, and then on top of that, instead of hypervisor, right? So in the traditional world, when you're installing VM, you will have a hypervisor. You will install Docker Engine. It's a very small package, around 30 MB or so, which you can download, and it's available for Linux. Now it's also available for Windows 2016, where you can install. So this Docker Engine is the brain behind OS virtualization. So what happens? Anything that you install on top of Docker Engine, once you have installed Docker Engine, all these applications will require their operating system services. That operating system services is virtualized and handled by Docker. So now you don't need operating system for each and every application, because the Docker engine itself is sitting between your application and host operating system. What it can do is it can manage the communication between every application to the host OS, and this application will think that they are interacting with their exclusive operating system. If they need any services from operating system, that call will go through Docker engine, that will go to the host operating system. So essentially what they have done is they have abstracted the requirement for having operating system. So that means now I don't need to deploy a dedicated VM for every application. Now here what you see is you have a physical server. On top of that you have operating system, and then on top of that you have Docker engine, right? But it doesn't have to be like that. What you can do is you can have a VM running on VM, and on the VM itself you can have your Docker engine installed, and then on top of that your VM you can have your multiple application, app 1, app 2, running as a container. Now these isolated units that I'm talking about, every application runs its in own space, and that space is called container. And that's the key term, that's the technology behind and what makes it possible is the Docker engine. So any application that you try to create today and you deploy on the Docker, it will come in form of a container image, and then you create an instance of that image, and that instance is called container. So your every application will go in its own isolated container, and that when I say isolated, it's a user mode isolation. You don't get kernel mode isolation. That means in your kernel is shared. Your application A, B, C, every application is sharing the same kernel. So if you're really looking for kernel mode isolation, wherein every application has exclusive access to kernel, and one application, one-to-one mapping of application in your kernel mode of your operating system, in that case probably container may not fit into your requirement, because container shares the kernel, whereas in case of VM, it doesn't share the kernel, you have dedicated. However, Microsoft has come up with another technology where in the container itself they're also offering kernel mode isolation, which probably I'll not discuss here, but maybe in future session we can talk about that. In terms of the container, as the difference between VM and container, the container offers your OS virtualization. It offers user mode isolation as opposed to kernel mode. So that means your all the processes runs into an isolated island and container, and that container interacts with Docker Engine, and Docker Engine makes it possible for them. The benefit of container is it promotes portability. How it promotes portability? Because now all this, since your operating system is abstracted and this is a self-contained unit of your application, and your bins and all library file which is needed for that application is part of that container, you can easily port onto different hardware. So let's say if you have container running on Linux Box 1, and from there you want to move to Linux Box 2, which is a different architecture. You don't have to rewrite the code. You just go install the Docker engine on the Linux Box 2, and you just move this container as is to the other one. So that really abstract the actual. You don't have to do the refactoring of the code. So that really promotes the portability. That's one of the beauty that has really spurred the use of container now, because now you can move around very easily. Not only that, you can have container running on a laptop, and you do your testing, and once that testing is done, you can deploy the same container as is on a production environment. So that was the beauty of the container. That's how it has caught attention of industry leaders and industry experts, and nowadays everybody is using container, and right now container is available on Linux as well as on Windows. So Windows is a relatively new phenomenon, so they started supporting Windows 2016. So Microsoft partnered with Docker to offer container services on Windows 2016. So that's basically the difference between a VM and container, right? So before I move on, any question on this slide?
Yeah, Neeraj, it's Naveen.
Yeah, Naveen.
One of the participants said that you were going very fast. Interesting.
Okay. All right. No problem.
Yeah.
Sorry.
I have a quick question. This is Della.
Yeah, Della.
It's more a question of confirmation. Would an example of this, if I'm understanding correctly, SQL, which is a resource hog and basically has to have its own server for anything you do, this would be the ideal application. The container put your SQL services and system in a container, and then anything that uses SQL and shares the data, accesses the data, would be in your other apps. Is that a proper application of what you're referring to?
No. So not every application can be containerized. People are there who have containerized Oracle databases also. That's also a possibility, because Docker engine is very versatile. But that's not something I would recommend. And there is a whole laundry list in the workloads which can be containerized. So I would rather containerize an application or web app or .NET application, but certainly not database, because database is high I/O intensive and requires a lot of resources, physical resources. But in production, I wouldn't certainly do that for database. But
okay, so you would leave you would have we have it currently on a VM. So you'd leave SQL in its own VM with its own resources, and then take a additional server and do the container for the, as you just said, more of the web application side of things.
Correct.
Is that more
Yeah,
correct?
that's right. So I will containerize my web. I will containerize my application tier, but certainly I will not containerize my database. Can I do it? Yes, you can do it. But is it recommended? No. I mean, you want to, if you really want to containerize, and if you have like, legacy database, proprietary database, which is something you really want to make it portable, and you're okay with the performance, because there will be slight performance hit that, when you containerize the application, probably, you can use those. But, for SQL, for Oracle, I wouldn't prefer that, and I wouldn't recommend that.
Okay. Thank you for correcting my thinking.
You're welcome.
Neeraj, this is Sudayan. So, how can you choose the application which can support in containers? So, you said generally lots of application it won't support firstly, right? So, which are the application you can say? You said web apps and
Yes.
some other applications.
Yes. So, I mean, there is a list. There is also a guidance which is provided. If you can go to the Docker website, they will provide you that list. And plus, it's also you have to do your own, POC and do a try and test and see which workload, works for you and which can be containerized. So you'll have to do a performance testing and a POC and analysis to come up with. But in general, there are some guidance which is out there on the Docker website. And you can go and check out there. But in general, database is not recommended, and any mission critical which requires high IO intensive and which is a resource hog, probably personally I wouldn't recommend that to be containerized. But if it is something like the web or application tier, or any kind of processing workload that you're doing, those can be virtualized. And there are many images which are out there. So today you can go onto Docker registry, and there are millions of images which people have uploaded. So you can look at those. You can do your own POC and testing, and then choose what workload to containerize and what not.
Yeah.
All right. So in that's the case, if I go for the batching process, I'm going to choose this batching process for a certain time during non-business hours. I'm going to execute the batching process in Docker.
Mm-hmm.
So how it will be the Docker scan elasticity in cloud platform? If I have
yes. So maybe I can talk about the next slide where I talk about the container and container orchestration. Container orchestration is what gives you the elasticity, and it will dynamically manage the instances for you. So there are different orchestration tool which are out there, which does the elasticity for your container instances.
All right. So finally, how about the security in Docker engine level?
Correct. So that's why the security, I said, a lot of organization probably won't be comfortable sharing kernel mode, because if your kernel mode, let's say if I have an application and if hacker gets into my kernel and if he hacks into kernel, then he not only hacks into my OS kernel, but he also hacks into all the applications which I have here, because all these applications are using the kernel. And that's why a lot of security, especially in my organization, they don't really recommend it for highly sensitive workload or secure workload. They don't let it to be containerized. But if it is like non-sensitive, and also the performance side is also there. So but from security perspective, if it's non-sensitive and it can share the kernel, that's when you can use containers, because container shares the same kernel. It only provides user mode isolation, not the kernel mode.
Neeraj, just a small query. So is there any possibility of pass-through kind of settings that we can make in Docker engine?
So what do you mean by pass-through?
Normally, if we do the hypervisor thing, so you can just make a pass-through of direct access to physical hardware like a NIC card to the guest OS. Likewise.
Probably there would be, but I'm really sorry, I don't have an answer for you at this point of time, but I can find out if that's okay with you.
Yeah, no problem, no problem. That's okay with me. Thank you.
All right, so I'll move on to the next slide. We have, it's 1 hour session, so I'll have to quickly complete so that we can get into the demo. Demo is also going to take some time. So I talked about the container and I talked about the VM. Now talk about what that container service is offered in Azure as an offering. So we have Microsoft offers, there are 3 kind of services that typically they offer, and I talked about one is Azure Container Services. The second one is Azure Container Registry, which I'll talk about next, and then you have Azure Container Instance, which is a container service but a managed instance for you, and it's a PaaS offering from Microsoft. So what's Azure Container Services? Basically, in order to, if you look at the previous slide that I talked about, so what was the key component of the Docker? The component was that you need a host operating system, and then on top of that you will install the Docker engine. So that means you'll require an operating system. On top of that, the Docker engine runs. So in the real world, probably you can use your physical server. On top of that, you can install operating system and you can install the containers engine, Docker engine. But in Azure, and this container engine can be installed anywhere. You can install it on a Linux box. It can install in a VM. You can install in a virtualized. So like now Microsoft offers nested virtualization within virtualization. And if you really want to do that, you can also run the Docker within the virtualized environment and virtualized environment within that also you can do that. So the Azure Container Services is basically nothing but it's a cluster of VMs. So when we provision, as a part of this demo, when you'll see that when we provision the Azure Container Services, you'll see in the background it will provision a set of VMs for me as a part of the this provisioning. So it will create a VM skill set, and then on top of that, obviously it's going to be a Linux VM, and then on top of that it's going to install the Docker engine for me. And once the Docker engine is installed, I will be able to I'm ready to basically install any containers, any images that I can either I can pull from Docker Hub, or I can create from my own repository. So when I say own repository, Azure Container Registry, so that could be for an organization, that could be small within that organization. It's a private repository, whereas the Docker Hub with the registry is there, it's for public. And even they also have offering for private repositories, so you can buy that from Docker also. But if you're in Azure, you don't have to really go and subscribe to Docker Container Registry. You can create your own with Microsoft. So that's one thing. So I mean, in terms of the container services, so compute is your part. So you have compute, you have VM, and then on top of that, this engine, the Azure, the Docker engine gets installed. Now, once I have all this, I need somebody who can manage, who could be the manager, who could be the orchestrator. So Microsoft, offers you three kind of orchestrators. So Kubernetes is a technology. It comes from Google House, and Google has used their own technology for Borg, if I'm not mistaken. It was the Borg that they were using in-house for container technology, and then after some time they made it open source and they released it to the public, and that's what becomes Kubernetes. They have not open sourced the Borg, but the Kubernetes is what is available today. So Kubernetes is an offering from it's not it's open source, but it inherits its all characteristics from Google, right? So Google, you can say Google was the father or mother, the parent of the Kubernetes. Then you have second orchestration engine. Basically, you have from Mesos DCOS. So this is from the Mesos it comes. And then the third one, which is Swarm. So right now, if you create an Azure Container Service in Azure, Microsoft offers you any kind of orchestration service that you can use. Now, what is orchestrators? So orchestrator is something which takes care of your dynamic load balancing. It takes care of your health of your container. If one container is down, it will automatically spin up another instances for that container, and it will take care of elasticity and overall management. So you can say that it's a cluster manager. It's like you create a cluster of containers, and that that cluster needs to be managed. So you can choose any kind of orchestration. So you have three kind of orchestrator tool, which is offered by Microsoft Azure. It's Kubernetes from Google's side, DCOS, which is Mesos, and then the Swarm is it's a Docker offering. So all these are free of cost. You can use it when you create it. Only when you create an Azure Container Services, you're only paying for the compute and the required infrastructure that is needed to create that container service cluster. So you have your compute, you have your storage, you have your network, and you have load balance. And we will see that when we create this container service cluster, we'll see that in the background that everything gets provisioned. In terms of what kind of images you can install on Docker, you can install Docker images. So like, as I said, you can download it from the Docker there, or if you want to bring your own image, if you have a custom image, you can install that as a part of Azure Container Registry, and from there you can, create an instance and you can bring it and you can use it basically. In terms of orchestrator, as I said, you have Kubernetes and then Mesos and then Swarm. So these are the container services as a part of that Microsoft, you get it. And then in terms of services, in terms of orchestrators, you have these three options on your table, and depending on what's your comfort factor, a lot of organization, I don't want to give a name, but in terms of any organization enterprise level, since Docker was there for long, so probably a lot of enterprises prefer Swarm as their orchestrator, and some of the universities and innovation-driven companies who are on cutting edge and bleeding edge, they use Kubernetes. There are other companies, they also DCOS, but not to be seen as citing any of these orchestration technology. But what I have seen is usually enterprise uses Docker, Swarm, and then followed by DCOS, and then Kubernetes. So this is, but the Kubernetes adoption is on the rise, but that's something you have to. It will depend on your organization what kind of orchestration tool you would like to use. All right, any question?
All right, Neeraj, this is Sudain. So again, Kubernetes, it's really a fantastic and tested in a production environment. So I'm not sure about the rest of the two. So how can you do the capacity planning if you run in the cluster? So how can you identify? I have a bunch of Docker's engine going to deploy in the cluster. So how can you ensure about the cluster is capable to handle this load?
Yeah, so you're talking about so this orchestration tool will handle your container and container load balancing. So if one container is down, it will spin up another container and it will move around between your underlying VM skill set. Now in terms of what will happen to the capacity, you can configure your capacity utilization at the VM skill set level, or you can also use Azure Service Fabric. That's also another option wherein you can specify that if my capacity is, let's say, around scale set capacities, CPU utilization is around 80%, please add another node into that, and that will deploy that for you. So that's from the node capacity perspective. But as far as the container and the health of container and where it will be placed and how it should be placed, whether one container is down, that will be taken care of by your orchestrator.
So how frequently the health checks will manage?
Yeah, I don't have exact statistic, but I assume it's very frequent, and they check it on a very regular basis. This orchestration tools, so I can get you those statistics if you're really interested after this session.
That's cool. So have you tested any latency when you run the application in between any of the container service?
So as far as container, remember in these containers you have two options, right? So all these containers are sitting on a VM skill set which is connected to each other in Azure using Azure Service Fabric or Azure Backbone, and the Azure Backbone is it offers you up to 25, so you have very high speed connectivity. So in terms of latency, you will feel the same latency. You will not feel the same amount of latency which because whether it's a VM or it's a container, it's the same backbone that they are using. So we have not seen any performance in terms of network, But in terms of the actual workload being containerized, yes, that's very subjective. That will depend on what kind of workload you are running.
Cool.
Thank you. And thank you for asking a question. It keeps session very interactive, and I appreciate all your questions.
No worries, man.
All right, so I'll move on to the next slide. So I talked about the Azure Container Services, wherein it's a you create your VM skill set. On top of that, you install Docker engine, and then and then you run the container. Now, how do I run the container? From where I will get the container images, from where I will get this different images that I have. So I talked about the Docker registry. So you have Docker registry, but as an organization, probably I wouldn't be comfortable using any public images. I have my own golden image. As in case of VM that you have, a lot of organizations, they don't use any marketplace image. They use they use their own image that they bring from on-prem, and they call it golden image. So similarly, Microsoft also offers a repository. So Azure Container Registry is a repository. It's a private repository where you can store your container images. Again, these container images are Docker based because Microsoft the underlying technology for container is the Docker itself. So the container image format itself is a Docker. So you can have your own private registry which can be exclusively dedicated for your organization, and that organization will have access, and you can upload all your images there, and you can use that, you can consume that at the time of deployment at regular places. That's the beauty of Azure Container Registry. Again, it's based on the Docker, so it utilizes in the background. It utilizes Docker registry to protocol. So the Docker also has its own registry offering. They have public registry, so with the millions of downloadable images that you have, thousands and hundred thousands of images that are available there for you to download, which is some are copyright, some are copyleft, depending on what kind of licensing agreement they have. And Microsoft is leveraging that because Microsoft and Docker has get into strategic partnership wherein Docker is helping Microsoft to bring in the container technology on Windows 2016, and that's where now Windows 2016 also supports container with help of Docker. In terms of images that you have available that you can store in this, or from the Docker also, they have both kind of images. You have Windows images, Windows-based images, and Linux-based images. So if you have, if you're looking for any image on Windows 2016, you can use that. So, and on the Linux side also, you have those images. So any it's up to you what's the preference. But Linux is the most preferred. A lot of people, and it has been there for 5 years or so. In fact, it was there in the Linux world for 15 years, but it was popularized by Docker some 5 years back. So Windows is catching up. In terms of the container registry, some of the terminologies that you should be aware of. So registry is your top level container. You can say this is a namespace where you will store all your images, container images under that. So that's the registry, and the two kind of offering Microsoft offers you. One is, and again, registry is nothing but a storage location. It's a name given to the storage location. So you have storage account where you will store, all your images. Similarly, registry is also backed by a storage account. So all your images goes into and sits in a storage. And it says, so the two kind of storage accounts, right? So you have managed and unmanaged. So registry uses the unmanaged, which means you'll have your standard storage account and you manage those storage account and all those. Whereas a managed registry is, it will use the managed disk or managed storage account for you. So in that case, probably you don't have to really worry about it, and it gives you 99.999%, that is 5 nines of high availability for your container registry. In terms of repository, so we talked about registry. So registry, your top level, and then within the registry, so you have repository. So if you remember, you have storage account, and within storage account you have your blobs, and within blobs you have containers. So similarly here also, you have registry at the top level, and within registry you can have multiple repository. So now this repository are it's a group of container images. So when I say group, you will group all your images. Like I have my application images. So I have .NET 4.5, .NET 4, .NET 3, .NET 2.5, and all these images, probably I will club this and call it a .NET repository. Then I can have for JVM, I can call it JVM repository. I can have similarly for Python. I can similarly for have for my IIS, I can have IIS 7.5, IIS 8, and so on, depending on what it is. So you can group those based on the purpose, and you will put it in a repository. So you have registry, and then inside registry you have multiple repositories. So this is at the top level you have registry, and within the registry, so let me just draw it so that it will be easy for you guys. So you have registry, and then within the registry you have different repositories. So you have rep1, which will be, let's say, .NET, and then you have rep2, which could be Java, right? So, and then within that repository, so that's a hierarchical organization. So you have registry, then you have repository, and then within the repository you have different images. So I can have image for .NET 4.0, I can have image for .NET 3.5 and .NET 3, and so on. So these are my images. So within repository you get to see the images, right? And then once you create an instance, I can have multiple instances of the same image, and an instance of image is called container. So I can have at any point of time, I can have 3 instances of .NET 4.0, and similarly, I can have more than 5 for .NET 3.5 and so on. So you can have multiple instances of the same image. So each instance of an image is called container. So you have registry, within registry you have repository, within repository you have images, and with the image, once the image is the last, and then once you create the instances of images, those are called containers, and you can have multiple instances of the same image. So you can run the same application with multiple instances. So that's how hierarchically it is organized. These containers is based on, as I said, is based on the image, and what kind of image you have is Windows based image or Linux based image. So this is how the hierarchy of a container look like, the container registry looks like. Any question on this?
Can we manage version control on the repos?
Yes, you can. You can in fact also tie this up with the GitHub and all those, and you can check in from there. So there are a lot of features which Azure Container Registry offers, and version control is one of those. RBAC is also, it also offers you role-based access, like who can really download or create an instance. All those things are there. Azure Containers.
How can I add registries? How can I add the images into the registries?
So once you create the registry in your GUI, from there you can either directly upload it to the console, or you can also use other tools you can use Jenkins to push it. You can use GitHub. The various integration points that Microsoft offers.
Okay, thank you.
So can we do the API integration with the VM if I run the container services?
What do you mean by yes? API integration in terms of container management, or API integration in terms of application running inside the container?
Applications which is running inside the container.
Yeah, you can do that. You can host your API instances. So let's say you want to create an API gateway. That API gateway, if it is suitable for containerization, you can. So when you create a container, as a part of that, you also get a web and a port number. So an IP and port number. So anybody who wants to interact with that will have to use those endpoints. So it's reachable from, depending on how you configure it, internet or intranet.
Okay. But you said integration with the Jenkins. I have to test the code, which I have tested. The development team provide the code, which I have to test it in Jenkins. So in that Jenkins, the front end, it's using by container services for web application or whatever it is. So if I run the code, if there is an issue, or else I want to revoke it, or else roll back it. So if there is any other option to do the rollback here?
Not from the container perspective. You can go back to your previous. You have option of the container, it does offer you, you can stop the instance, you can create another instance. It takes 30 seconds to spin up another instance, and you can do those through automation at the front.
So, yeah, hi Neeraj. Hi Rajesh. Hello. Yeah, I can answer this question regarding the Junkin one.
Yeah,
So,
please go ahead, Rajesh.
yeah, so in case whatever example Uday I think mentioned, so in case you have that any downtime or any issue with the other instance, we can write the shell script, and that shell script basically have a multiple image, and there we can and validate that if any issues with any portal or website, we can basically go with the another basically create the another instance for the other image, and that will basically pull out your old code, previous code, and that will give the rollback feel, and we can execute our application or call the services on that instance. So it's completely can be managed, and there are various ways. The one I explained with the shell script.
Yeah. So I mean, yeah, you can manage. There are ways to achieve that. You can do that. And as I said, since container, another advantage of using container is, which I probably missed to mention, as opposed to VM. Even if you create a VM, fastest is at least it takes 5 minutes to bring up an instance, whereas container it takes 30 seconds, less than 30 seconds to bring it up. So that's also, it's very fast because you're not creating the entire operating system image and building on top of that application. You're going to reuse the existing operating system. So that's why it's very fast to reboot or create a new instance of a container or an image.
Okay.
All right, so let's move on to the next slide, which is the demo. So what we are going to do is we have limited time, so maybe I'll have to stretch for another 10 to 15 minutes, and I do apologize in advance. But what we'll do as a part of this demo, we will create Azure Container Service instance through GUI, and then we will also see how to do it using the Azure command line interface, CLI, Azure CLI, which is you have PowerShell and then you have Azure CLI. PowerShell is Microsoft and Azure CLI is from the Linux community, Linux fraternity. Since this Docker is totally on Linux, so probably we would use Azure CLI to provision the Docker Swarm or Kubernetes cluster, and that will be managed by Kubernetes. And we will also run a website, and I'll show you how that looks onto the portal. So let's go ahead, get started on the portal. So let's come here. So the first thing first, what we will do is, as a part of this demo, we will create a Azure Container Service instance or an Azure Container Service cluster, and how it looks through the GUI, so that you can see the field, what's going in the background. Once it gets provisioned, we'll also see what all resources get provisioned as a part of, the Azure Container cluster that we provision on the portal. Right? So you will start, let's go ahead and create a new, so I will say plus new, and this is where I will search for container and it will show me Azure Container Services. So you can see you have Azure Container Services. I talked about Azure Container Instance, which is PaaS offering, which is still in preview. And then you have Azure Container Registry. So, but right now I'm going to go ahead and create an Azure Container Service. So once I select on that, they also call it in a short form ACS, Azure Container Services. I will click on create. Let's provide some basic information about this. So this is going to be the name of your Azure Container Service. So let me call it Cloud Easy Container 1, right? Resource group. So what I'll do is let me create a new resource group for this. Because I will need, in the background it creates the provisions, all resources including, and I'll show you load balancer, VM skill sets, and the network and subnets, everything. It's the same like on the Service Fabric line. If you would have seen my demo in Service Fabric, it does almost same identical pattern. So let's go ahead and give it a name. So I already have Docker 2, so I will give Docker 3. And then you choose your location, whatever location you want to choose. I will leave where it is, West Europe. Let's go ahead and say OK. So once you provided the basic information, you have to choose what kind of orchestrator you would like to use. So I said orchestrator is the brain, is the cluster manager of your container cluster. So you can choose DCOS or Kubernetes or Swarm, which is the Docker Kubernetes. Again, Google technology which has come now, it has become open source, or Mesos DCOS. So it's up to you what you want to select. I will select Swarm. The next is you have to specify the name prefix. Now this is internet resolvable name that Microsoft will add that as a prefix, and obviously it will borrow a prefix from Microsoft perspective. So this is going to be your DNS name prefix that should be unique within the namespace under the Microsoft namespace. So let's go ahead, give it a name. We'll say Docker 1. See if it is unique. Yep, if it is if it is not unique, then probably it will give you an error message. So if I say this, okay, that is also unique. But anyway, I will leave this. This is your username. In any VM that you build, that you have to specify your username. So I just give EA. Now this is where it gets interesting. So it's slightly different when you access a VM in Linux VM. So Linux VM offers you two ways to access. One, you can use username and password. The second option that they offer, the most secure option that they offer, is public key and private key. Anybody who has used certificates, which is private, is the corresponding private key and public key. If you encrypt something with your public key, it can only be decrypted by the corresponding private key. So that ensures that the intended recipient can only decrypt it. So same concept here, also called SSH key. So basically what it is doing is, here it is asking me for the public key that will get associated with the VMs that will be part of this Swarm cluster that I'm building, and then I will use the private key of that, which I exclusively have access to that private key to really access that, and I'll show as a part of demo. But how do you generate an SSH public key and private key pair? Secure shell, it's also called secure shell, and it uses RSA protocol to generate that. You can download free tool. If you're on Linux, Linux has an inbuilt tool to create that. But if you're not on Linux, if you're on Windows box and you really need to generate an RSA key or SSH public key, you'll have to download a tool called Putty, Putty, and that comes when you install it, comes with a tool in terms of for generating. So it has a tool called Putty Gen, so which generates the keys for you. So basically I can paste the link for you in the chat window, so that if you want to really download, you can download that, and it also has the link how to really use this technology. So but I will show you how to. So once you'll have to download this Putty Gen if you're on the Windows VM, period. Now how it works is you will open your Putty Keygen. So let me just open it from the scratch so that you know what I'm doing. So this is the the tool that I use, so Putty Gen, and then once you open, this is the console how it's going to look like. You come here, and this is where you see, look at this. This says click on public key and private key pair, right? So what you can do, you can click here, and this will generate public key and its corresponding private key. So private key you have to save on your laptop, because you will use that when you're connecting through the terminal, SSH terminal. All right, public key is what is needed right now. I'll have to paste it here, so that it can use that public key and associate that to all the VMs, so that whenever I remote into or SSH into those VMs, those Linux VMs, it will match my corresponding private key, and that private key can only be owned by me, because I'm generating and I'm storing it, and I'm safely storing it. So let's go ahead and click on generate. So when you click on generate, it will ask you for randomness. It says you move your mouse over the blank area so that it will generate some random key for you. If you don't, then it will slow down. So let me move it around. Okay, so this is what it has done, and you can see here option. I have option of saving private key and saving public key. So there is a gotcha which I have learned by my own experience. If you save your public key from here and then you open it in Notepad and bring that key over here, you will have challenge. So rather than doing that, what you will do is, since I need the public key, I will copy this public key over here from this text box and paste it directly into this window here. So that will validate my SS, and you can see that there is a tick box. It is followed in the perfect format. Now what you need to be very careful is you will have to save your private key. If you don't save it, you will not be able to connect to these VMs using your private key. So we need that. So what we'll do is we'll go ahead and save, and when you're saving, it will ask you to put in a passphrase too, because these are sensitive keys. So do you want to passphrase? I don't want to save it with a password, without password, so I'm going to provide a password. And then I say save private key, and it will let me save. So I already have one, so I will go ahead and give it a private key 2. And so this is fine. So now I got my public key, I saved my private key, so I'm good. I pasted that public key here, and then this is where you have specified the master count. Now what is this master count? This master count is your how many cluster manager you will have. This is basically master and slave concept. So master is your swarm master, which will handle this. So how many you need? 1, 2, 3, depending on how many, 1, 3, and 5. So I will just stick with 1 because I'm not doing a production one, but if you're doing production, you can go with 3 or 5. So let's go ahead and say OK, and then finally here it will ask me for the actual VM on which the Docker engine will get installed. Right, that's where the Docker engine will get installed, and I'll have to do the processing and all those. So how many agent counts? So these agents are the actual VM on which the Docker engine will be installed, and then you run your application inside the Docker engine, or inside the container which is running on the Docker engine. Right. So I will again I will leave it to 1. So, and then you can select different VM size if you really want to, depending on how many containers you would like to run and all those things. You can choose different CPU sizes, different VM sizes that you have. So let's look at if I have something cheaper which can save me some money, because I don't have that much money in my MSDN subscription. So I have this. I can also use F2S or any other, but let's
you can use A series, just selecting HDD.
Okay, yeah, that's fine. So let me use a DS2 V2. That's fine. So I will use that, and I say okay. Now once that is done, this will give me the validation. This is confirmed that all my orchestrator is my swarm, the cloud is a Docker 1, EA, this is my public key, I have corresponding private key, master count is 1, I have not enabled VM diagnostic, I have agent count is 1, and this is the VM size. So I say okay, and then it will start the provisioning. Now while it is doing in the background, what I wanted to show you, it will take some time. In order to save some time, what I have done is I have another instance which is a Docker 2, which I have rather than provisioned through my script. So I have a script wherein the one that I showed you, it's a proper cluster with the a Docker Swarm manager, and then that manages the entire infrastructure, which will get provision. But then additionally what I have done is I have also, just for POC purpose, I have created a script, or that script is also there in the Microsoft. It's not I have created, but I have modified it to make it work. What that script does is it will create a VNet for you, it will create a network security group, and it will just install a single VM, and on top of that it will enable the Docker engine, and it will install nginx web image as a part of the Docker, and that's what I have done. I will show you that script, and we will hit that website from the internet, and we'll see that that's up and live and running. So let's look at the script that I have. So let me maximize it. So we'll go by one by one. Basically what I'm doing. Is it visible to everybody, or should I increase the font? Okay.
That's good, Leeraj.
All right. So,
Yeah.
the first two line, what are we doing? It's a routine. Every script that you will have, you will log into your Azure subscription using login Azure RM account. That's a command line that we use. Then you select your subscription. I have multiple subscription. If you have only one subscription, probably you can skip this line. And I will also upload this script as a part of my blog that I usually publish after the session, and also I publish the recording. So there you will have access to this. But just to make sure that you understand what I'm doing and how it's working, right? Then your fourth line is we specify the resource group. We have to create a new resource group. So I'm going to give it to Docker 4 because we want to provision it. Location, which Azure region you want to provision it in. So I have selected West Europe. The VM name, what is your VM name is going to be. So I have given Ubuntu. So if you want to give anything else, you can give that. That's also fine with you. So I can say Ubuntu 1 for this guy. This is where we are specifying, username and password. So by default, any VM that we create in Linux uses Azure user is by default our user account, and it's going to create a blank user and password. We will not like to use the password because we will be using. Remember, we will be using our public key and private key pair, and we'll come to that section where we are using it. So, once you have collected your username and password and stored it in a secure password object format, this is where we are converting this into PS credential format. It's ready, to be utilized. We will use it the next time when we create the VM. Then moving on to first thing first, we create a resource group so that we can group all the resources under that resource group. And we can use that so that it's ease of use, and once I'm done I can delete my resource group so that I save money because all these are for demo purpose. So this will create this is going to create a resource group for you. The next one is what we are doing is we are creating a subnet. If you look at it, it's creating a virtual network subnet config wherein I'm specifying my subnets. This is going to be my subnet /24. Then this is where I'm creating my virtual network. So virtual network will have multiple subnets. So the address space is 192.168.0.0/16. 1.0/24 is my subnet prefix. You specify your virtual network, commandlet, resource group, which location you want to create, what's the name of your VNet, and then your address prefix, and then what all subnets you want to bring in. So I have only one subnet, so I specified that. Then we are creating a public IP. That public IP will get associated to VM that I create. So you can see that public IP, we are creating a new Azure RM public IP address. We specify the resource group name. We specify the location. Again, the same pattern. You have to specify resource group and location. Every resource that you create, these are common parameters that you have to specify: resource group name and location minimum. And if you're creating anything new, all the commandlet will start with new most of the time. So any PowerShell commandlet, if you're really looking into it, you have action, or rather verb, and then you have object. So if verb is new, remove all these are your verb, and then this is the object. What I'm doing new, I'm trying to create a public IP address, right? Now, in terms of what is going to be the name of that public IP address, I'm generating a random name because you don't know which name is already taken, so that's why it is. Then you have your allocation method. This is assigning a static. If you don't want static, you want dynamic, you can also do that. That's perfectly fine. But this script is going to give you a static IP address, and that IP address will be associated to the VM. Then next we are creating a SSH rule as a part of NSG. You know that network security group is what is the firewall. By default, SSH port number 22 is not enabled, so you'll have to enable that. Then only you can remote into your Linux box. For Linux box is SSH 22 port. For Windows it is RDP, which is 3389 port. So basically what I'm doing here, I'm creating an NSG rule which is saying it's an inbound direction, priority I'm giving 1000. It says source port is asterisk, which means anybody can come in. So and then the source port range could be anything, and then destination port is 22 and access is allowed. So this is basically I'm creating a rule, NSG rule. So this will make sure that I can access it from the port 22 from outside or from internet. Now I'm creating another rule for port 80 because this is a website which I will hit from internet, so I want to make sure that it's accessible over port 80 also. So I'm doing that on port number 80. So the same thing. Here it is for SSH. This is for HTTP. Once these two rules are created, we associate that to NSG object. So here it is the NSG object that we're creating. We're saying new Azure RM Network Security Group. It's again same thing as I said, the same pattern, resource group name and the location. You give that. You specify your security group name, and then this is where you specify the security rules. I had only 2 rules, so I specified if I had more than 2 rules, I need 10 rules. So you will specify all those 10 rules object. So any this $sign which starts, it represents an object or variable. So you can specify all those here. So this is going to give me my NSG. This will complete it. Then finally, I'm creating a NIC card, network interface card, which will get associated to the VM, and I'm associating my NSG to this. So you can look at this. With that, I'm also associating my public IP that I have created, network security group that I have created earlier, and then also the subnet that's going to be in there. So with this, I complete my NIC card. And then finally, once that is done, now it's time to provision the VMs. So this is the section where we start provisioning the VM. So first you need the configuration information about your VM. So we start with the VM config variable, and we say new Azure VM config, because we have to keep adding information, add on to the information about the VM configuration. That's why we start with the config as a virtual object. Then finally we commit it. When we create it, we use that virtual object and create that on the Azure portal. So it's new Azure RM VM config. I specify what VM name I have already given the name on top of that, so I'm going to use that variable. Then I'm specifying the VM size, what kind of size this is, and then I'm setting operating system. I need Linux. This is my computer name. This is my credentials. Then disable password authentication, all those, and then finally we also specify what is going to be source image. This is going to be Ubuntu server, SQS 14.0. You can select different options that you have. Then version, what is the version you want to use? I want to use the latest one. And this network interface card, then we are adding the network interface card to that VM config file. Once that is done, this is where we are basically trying to associate our public key into SSH key. So you can see that I have this file which I have stored. So by default, when you try to remember, I said that this is a public key, right? So here also you can save public key, but if you save public key from here and into the file that I have mentioned over here, which is id_rsafe.pub, it throws an error. The reason is the formats are different, what is shown over here as opposed to what it saves. So always remember, if you're using putty keygen, copy from here, and if you're going to use this script, copy from here, and then create a file name called id_rsafe.pub. So I will show you. Let's come, and this is by default at the location that I have specified. This is in my profile folder, and under there I have created an SSH folder. That's where I have this. So you will come here. If it is all not there, you just create a notepad file with .pub and you paste it here. So once you paste it in this form, this is going to be this format. So once you paste it, you are ready. You are good to go for your script. Script will read from here and get this content and use that for provisioning the VM. Okay, so let's come back here, and since this is going to be the public key, so what I will do is I already have that, so I will not use this one. This is going to read from this file id_rsafe.pub. Then we add VM config, and basically this is where we are associating it. This is going to store this authorized key onto the server that we will provision. And finally, this is where we are creating a VM, new Azure RM VM. Use again resource group, location, see all this, and then finally what we have added, we have added VM config, all this information that we have added, and this will create a VM for you. Once this is done, then we are installing the Docker and containers. We are specifying that we need the Docker. We need port 2375, that's the management port that. And then what kind of port it is, it's a web that I want to install. I want to install image, and it's nginx image, which is again Apache, the web servers, and then the port, which port it will listen. So it's 8080, so it will listen on 80, and then the backend port is also 80. Once I've specified those settings, this is where I'm setting my VM extension. So basically it will install the Docker VM extension of that VM, and it will provision all the setting from public setting. It will take the public setting and then it will enable that. So once that is done, you will see that it gets created. So let's go ahead and execute this. Before that, any question on this? I know it's a lot of things to take in, but if you have any question, let me know.
Neeraj, Shakti here.
Yes, Shakti.
I have one question. So through the PowerShell, it is clear like we are first deploying VM, and on the top of that we are using container service.
Correct.
But you created container service through the portal. So in the backend, how it deployed? I mean, it is using dedicated VM or ScanSet?
Yeah, that's a good point. So I was discussing this because I was waiting for this to complete. So it looks like it completed. So let's go here and see what is there in the background, right? So it creates a scale set, it creates load balancer. Let's look at what all we have. So we have storage account obviously to store our VHDs and all those, and plus the images that we will create for the Swarm. And you can see that I have container service that's got created. I have this scale set. You can see the Swarm agent. So Swarm agent is the actual VM that which will host all these Docker engines on top of that, right? Then I have this load balancer, which is for the Swarm agent. Then I have Swarm master. I selected only one, so I can see only one Swarm master. And then I have availability set. It has to be deployed in availability set, right? Otherwise you will have problem and challenge. Then I have the public IP so that I can hit the master from public, and I can manage my Swarm engine. So if you look at closely, what all we have storage account, we have container service, we have virtual scale set, then public IP, then load balancer, again virtual machine, which is for the Swarm master, NIC card, availability set for Swarm master, and then you also need the VNet. VNet is there, and within that you will have the subnets and all those. So this is what. So basically now when we create as Azure Container Service, it uses a template. It's a JSON template which Microsoft is using in the background for you, and it provisions everything for you in this, including your network, including your load balancer, including your scale set. So let's look at the scale set what we have. So we have selected only one VM, so we'll see only one VM as a scale set instances. So we should see only one. So you can see, right, I have only one instance. So if I have selected 2, 3, you can have thousands of instances, but I have selected, I don't have that much budget in my subscription. It's an MSC subscription, so I just selected one. But if you have selected more than one, all those instances will get listed here. But what I'm doing is I'm doing a manual install, right? That's a good point that you brought up. This is what this is going to do is this will manually create just a VM, a Linux VM, and on top of that it will install the Docker extension, VM extension, and then it will enable Docker, and it will spin up that instance. So let's quickly run this. I'm not going to log in and all this because I already logged in, so I will just skip that section and then I will run this. Let's go ahead and run it. So basically in the background it will go ahead and create it. So in order to save time, I already have the same instance up and running, so that we will save time on we don't have to wait for it. So let's come here, resource group, and I have Docker 2 resource group where I have created a VM, and that VM is fully up and running. It's called Ubuntu, and I also have an SSH into it. So I will close this and I will show you how do I connect using SSH to that VM. So let's close this session. Let's check the public IP of this guy because we'll need that public IP. So what is the public IP? This is the public IP. Let's open PuTTY. There it is. And I specify the host. It could be your public IP. Now, one thing you have to keep in mind that for authentication, you'll have to specify the private key that you generated at the time of generating public key. So every public key has a corresponding private key. Private key you will store it on local machine as a file, and public key is what you will associate will get onto your VM that you're provisioning. So when you log in, you present your private key, or you encrypt your session with the private key, and it uses a public key to validate it has indeed come from the person who has access or who owns that private key. So what you will do is, once you have specified this IP, this is the first, you will come in SSH, and this should be auth. Yeah. So under auth, this is where you specify your private key. So let's go ahead and specify the file that I have for private key. I will not use the 2, I will use the first one. That's the one I have used for this instance. And I say open. So basically it's going to open. Now it is asking you how you want to get logged on to this. Do you want to, what's your user? So my user is Azure user. Always remember, when you're creating in Azure, it's Azure user. And then it will ask you for the passphrase. Remember, when we were saving the private key, it asked me for the password, and I did give the password. I remember the password, so I will just type in that. So it logged me on. Now if I say ls, I don't say anything because I have not created anything. But now let's hit this website, this IP that I have from on-prem, from the website. So you can see that this IP, anybody, I'll just paste this, anybody who would like to, or you can also do one thing, if really this is the public IP, I can make it really user-friendly name, and I can give it a DNS name level. So let's go ahead and give this name and save. So we can also give a DNS name to a public IP. So that way, instead of IP, you can always use the name. So let's close this and copy the name that I have. So refresh. So I'll copy this. Let's copy this, and you can also hit this, from here. So if I hit from here, it will same website. Basically, it's an Nginx website. Now let's examine what is there. So if I say Docker PS, it will show me that I have this. Let's just see if I. So sorry. So you can see that I have this. I ran the command docker ps, right? And this docker ps gave me that I have image running nginx. It's running as a daemon, and it's created 3 hours ago, and the port number is 8080. And let's see. You can see the port number is 8080, and this is up for 3 hours. And this is nginx, and that's how we are able to access it. So any kind of commands that you want to run, you can run. So basically it starts with docker, and ps is the ps, and if you want a docker network and ls, so it will list all the network that you have for the Docker. And there's so many commands that you can use. Basically, if you really want to play around. Again, now this gets more into the Docker and the container. It's all the command is from the Docker engine. This is the Docker engine command that you are basically using. So there are so many commands that you can kill. If you really want to kill, you can do that. You want to start and restart, you can do that. You want to if you want to stop a container instance, you can do that. If you want to do the stats, you can also look at the stats. So all those things that you can do. Again, it's about it's getting more venture. You have to venture into the Docker world, and that's where you will start doing this. This is more on the Docker administration as opposed to the Azure Docker services. So mainly this is what you get. So you install this Docker engine, and this is the command that you use to interact with that Docker engine that you're seeing right now. Similarly, you will also have Docker Swarm, and once the Docker Swarm is installed, you can use the Docker Swarm command lets basically interact and manage your Docker instances or Docker VMs running Docker engine on top of that. So basically, that's how you will manage it in terms of your website.
Neeraj, could you please show me the volumes of Docker?
Okay, yeah, sure. No, you want to see the version, right? I don't know. Hold on.
Okay, df space -h.
It's Docker
DF.
hyphen version.
Oh, yeah. So yeah, this is what I got, right? So version is 17.0.c. This is what you want to see?
Looking for the LDF and volume details. I can
Okay.
type df space hyphen h.
Let's see if we can do that.
So I
H for hotel.
Yeah, so you
Yeah.
have this.
Just, yeah.
And you trust me, guys, I'm not a Docker expert, so if you have anything, please feel free to jump in and if you really want to play with. Again, as I said, you can use this script. It will give you one machine instance. It looks like it's done. It's almost done. It's still running. So it's a one machine instance. Install Docker on top of that, and then just play around with it. All those things that you can do a lot of stuff with this. And if you really want to get into deeper into doing with, so then go with the orchestration engine that we have installed, and from there you can start managing your orchestrators, and the Docker Swarm, the complete. So I think we put it in this one.
So Neeraj, Rukhsar here.
Yeah, Rukhsar.
Can we do RDP to the container?
RDP, but these containers are not a VM, right? These
Yeah.
containers are an application, so you interact. Yeah, I mean, if it is a Linux image that you're running, you can do SSH. If that container is it exposes those endpoint. Now, depending on what endpoint it listens. So this container right now that I have, so if you look at this.
And one more question, because the Azure says Fabric also provide container-based node, so we can add a node type with container-based. So what is difference between or any limitation Azure ACS versus Azure Sage Fabric?
Yeah, that's a good question. So basically, the Azure Service Fabric will add, or they are started supporting. So now the microservices that earlier you were installing, right? So microservices would get provision onto all these individual nodes, and that the Service Fabric node manager will manage all those, correct? Now, the Microsoft also gives the option of, instead of putting this as a process on a server in Service Fabric, you can put that process as a container. So instead of that process running on the virtual operating system, now you can put that as a container. So basically, it's another wrapper for your microservice. So microservice becomes portable now. So you can port it around. You can move around, microservices, as opposed to if you deploy your microservice on the VM. That gets tied up, and you may have to refactor your code if you move from 64-bit to 32-bit or different architecture. But in case if you use Service Fabric, which already gives you microservice oriented architecture and all the benefits, and then you deploy that as a container, it becomes portable. You can move around the container. That's another beauty of container. So at least you can. I mean, right now you cannot move between Linux to Windows. Maybe it will come in future, but today you can move around between any Linux flavor. So you have Ubuntu and you have Red Hat, you have all those, you can move around between the same platform. But there is no portability between Windows and Linux.
Neeraj is Uday.
Yeah.
So we have seen here the two types of deployment of the containers. One through the PowerShell,
Yes.
which we install Ubuntu and extensions.
Correct.
And we deploy container in the single VM.
Correct.
The other one, which from the portal, the Azure Container Service by the master and the agent,
Yep.
Which has a scale cert and other services and
That's
load
right.
balancer. So the individual VM which we created, which doesn't have the load balancer and the scale set, which we require to create manually.
Correct. So if you are doing your own on your own, and you want to do it, you can create your own architecture. So you can create two VMs, and you can create a load balancer on top of that, and you can create master. All these things can be done manually. But if you do through this, the GUI that I did, this Azure Container Service, Microsoft is using a JSON script, a template, which creates certain storage account, which creates certain container services, then agent, then scale sets, everything. All this you can do manually. If you really want to do it, you can do it manually. But
in certain situations we may require as a new or production requirement, So doing a custom deployment, yes, we can move around, create our manually on our scale set and the load balancer. But when we create from the portal, that's wants the Microsoft support as well in the backend.
Well,
Because just want to share my yeah.
Go ahead.
Yeah, that's just want to share my experience, because as soon as we create from the portal, we get a support from the Microsoft. But when we do as a custom VM, we don't get the manual, or Microsoft support actually, just to give you this. But as a developer or anything they want to play around, yes, they can use the VM and deploy the Docker extensions, and they can just do the not for the production. If I'm just for yeah. And one more thing, the flexibility which we have in the Azure containers as a support, and it creates its own all the services and maintain it. And one drawback I see, if I want to customize the virtual network which creates from the portal, it's always 10.0.0 slash maybe 32, not 32, 16 or 8, which is a default address space, which I can't change it. So, but when we do in a custom VM, as you mentioned in the previous, like in the the commands, we can define our own address space. So that gives me a flexibility where I can go for the blue-green deployment. But as well as I don't have a support. But Microsoft said I can change the Azure container virtual network address space by using the ACS engine deployment.
You can see there, right? So I can see right now, I can also add, if I want to add, let's say add, I go ahead 192.168.0.0/16. It will take it. So right now I'm modifying the address space of this the Swarm VNet, and it takes it. But the only thing is, you will not be able to, I don't know whether you can delete, you can remove it, but then if your subnet is already there and it's using that, probably that's where you will have challenge, right?
Yeah, that's say already the resources of the Swarm subnet which are predefined, which is using by the containers. So unless that containers are not used by the subnet, we can remove the subnet. But here we can't remove the subnet, and adding the address space like 192.168, it's really just an option, but really I don't think from experiencing just feeling of.
I mean, you can add it, but will you be really able to use this? You will not be, right?
Yeah, and one more scenario, say I want to create one more container from the Azure console, which I can't select the same the Swarm orchestrator, the subset of all the Dockers which is there already. So I have to create a new VNet which is going to be a 10.0.0. The same subnet and the same all the containers which I am going to create newly, which is going to use the same IP segment. Say I have to connect between the Azure containers which I created previously and I have created newly. If I want to do a peering between that VNet to VNet, this VNet, I can't do that, because the same VNet has the same address space. I can't do the peering because there's a limitation. That's address space. I just thought of.
Address space has to be mutually exclusive for peering to work, or even for VPN. It's not a limitation. It's a technology, right? So if you have same address space, the routing will get confused, and how the routing is going to work if the same IP belong to different places.
Because most of the production deployment, they wanted to create a separate development in a separate Azure container service, and they wanted to integrate the UAT or dev into one VNet and another VNet using a peering. But since it's the same address space, we can't do the peering. I see this is a limitation. We can't change the address space, but they said it is not supported as of now. They're going to support quickly. And we can use our Azure ACS engine, which is a custom deployment. It's a type of what we created right now, a VM and the extension. But if we use a ACS engine, it creates its own the scale set, public load balance, public IP address and load balance and everything on its own. But only the limit there I see Microsoft doesn't support that containers. We can play around with creating our own address space, and we can create one more ACS using engine dev environment. We can do the peering between the VNet to VNet.
Okay.
But
All right. Thank you. Thank you for adding on to this point.
Thanks, Uday. So I have some other question related to that. Neeraj, this is Uday again. See, this is regarding about the Dockers and Azure support. So if I'm going to spin up a multiple Dockers in my environment, so where can I get the support if I need any
So
assistance or any support?
yeah, that's a good point. So if you're using this the way that I have done through PowerShell, in this case, you're installing a Docker extension on top of that. Probably you will get help for Docker extension, but anything goes wrong with the Docker, it's not performing up to the mark. You'll have to open a case with Docker and to address that performance issues or compatibility issues. But as far as skill set is concerned, you will get help for in the platform. You will get help for how to. But again, if application level troubleshooting has to happen, whether it's not performing up to the mark when I'm containerizing it, you'll have to go and open a case with Docker for support.
See, there are slight line in between Docker and hypervisor level in Azure, right? So if in case any scale set issue or performance issue, definitely we'll go and raise a call with the Docker. Docker can need a support from Azure, so we can collaborate with Azure and Docker to
Correct.
get a
You can.
support.
Yes, you can. I mean, in fact, you can start with Microsoft, and Microsoft is something called TSANet, Technical Support Access Network. I worked in Microsoft net support for 5 years, so I know about that. Even Rahul, he's also in the call. He's also currently, he's working with Microsoft in Global Technical Support Center. So we have something called TSANet, where in a case it starts with Microsoft, and if Microsoft assesses the situation and says that, hey, this is not a Azure issue, or this is not a hypervisor issue, this is more has to do with the Docker, they can engage on the same call. They can do a hot transfer, or they can engage the SME from, and they have people, and I'm assuming Docker is part of the TSA network.
Okay. And second question, we don't have any KMS in Azure platform.
You do have Azure Key Vault.
Okay, we can use the key vault in all the public and private keys can save it, and
Yes,
whenever we require, we can use it.
correct.
Right.
Yeah, you can do that. So you have Azure Key Vault, and Azure Key Vault can store keys, secrets, and certificates. All these things can be stored.
Okay. Cool.
All right. Any other questions? So, I mean, this is what I wanted to show. So let's quickly go over. So this is the website which is up and running, which I have deployed in a web, which is deployed on a VM. And if I look at here, this got completed. So now I should have a one-to-one VM. So just quickly, just verify that VM got deployed. So let's look at Docker 4. And I should see my VM. Yep, I see my VM one-to-one. VNet again, it's created. Network security. Let's look at the network security group. We have assigned 2 rules. One for 22, you can see, and then one for port number 80. All the settings you can see, the destination, source, and the priority. So that's what is enabling. So if you don't have this port 80, you will not be able to hit on port number 80 running on the container. So these NSGs are not applied at the container level. This NSG is applied at the VM guest operating system, which is running on the VM level basically. So if you have, let's say, tens of containers running, one runs on 80, another on 443, and another custom port, and also all those ports need to be included here. So it's a very key thing to remember. If you have multiple containers running on different ports, please include all those ports here. Otherwise, it will not be accessible from public or places. Okay, so that's a key thing that I wanted to bring into attention. Most of the time, I do see people think that my container is up and running and then it should be good. Now you have to configure your NSG for each and every container, and this NSG is not at the container level. This NSG is at the OS level, and that's also can create some friction, that can, not friction, doubt in mind of your security team. Security team say, hey, now I have tens of application. You're opening 10 port to the same location, to the same place. So that's why probably that could be a challenge. So just keep that in mind.
All right, Neeraj, other question from my side. So how can you mitigate when you run the Dockers? How can you mitigate the DDoS and brute force issue?
So, for example, DDoS, if you have fixed customers and you know that your customer is going to come from your on-prem, right? For a lot of customers, they only have internet application, but so you can specify those IP blocks in your NSG so that it only accepts connection from the public IP of your office. That's one thing. Second, there are also tools which can protect your third-party tools are also there. You also OMS supports container analytics, so you can use those container analytics to understand if there is any kind of problem or any brute force or any kind of attack is coming. The security tools are also there, even in OMS also, so you can use those tools to do those things.
So you mean to say we have to deploy it in separately, then we have to integrate the traffic from the third-party tool and with Dockers clustering?
Yeah, you can use third-party tool, or if it is a web-facing, you can deploy a web application firewall (WAF) in front of that, and the traffic gets filtered, and then only it gets forwarded to your container in the background. There are ways you can do that if it is a web-facing. So WAF is certainly it's a must, right? You will put in a WAF. If like for example, obviously I wouldn't recommend virtualizing, but if you're virtualizing a SQL, then probably you can use a I don't know if there are SQL WAF or not, but Azure SQL does have ordered threat detection, but I don't know about the IIS SQL, but yes, you can use WAF to protect your workloads, container containerized application.
Okay, fantastic.
Awesome. So I think this is what concludes my demo. So in nutshell, what we did, we created Azure Container Services through Portal. We saw all these beautiful scale sets that it has created for us in the background. Everything was automated, and we didn't have to do anything. It created Swarm. It created Swarm Master for me, load balancer, Netcard, everything for me in the background. And then I can use it, and I can scale up in scale sets. It can go up to 1,000 and 1,000 plus VM. Then we also did a quick demo for doing a POC kind of environment. I have created my VM, and then on VM I've enabled the Docker extension, and then I have installed nginx, and I enabled my public key and private key, and then I use putty to connect to that. So I will share all those links as a part of my blog so that you all have access to this script as well as the tool, and how to use that tool and some of the articles. So as a part of those references, my blog. Yes, Dave, I will share that script. And usually what I do is when I finish my session in a couple of days, I will upload the recording onto my blog, which is blog.cloudeasy.com. You can also head over there, or the best place to go is cloudeasy /Azure Talk.html. This is the place where I post all my Azure Talk that I have done since the beginning. So I have more than 16 Azure Talks that I have done, and when you go into any of this, let's say for example Azure Talk Compute Part, and if there is any script which I use in that session, eventually it will take you to my blog, which is blog.cloudeasy.com. I post those scripts also as a part of that blog that I publish, what all I've covered, the videos that all you will get to see, plus any articles that I've used. Most of the time I do refer a lot of articles from Microsoft, right? So all those articles I do publish this as a part of the reference, you can see. Plus you can look at this, I have PowerShell script that I have, plus you will also look at the slides, so you will also get access to the slides. So always keep an eye. Your one place sharp is just bookmark this cloudeasy.com/Azure Talk. Every time I put it any blog, I will I'll put those links here, and from there you will branch off to my actual blog website, and you'll have access to everything. I make sure that you have, and in case if it is not there and I use some tool, and if you didn't find it, please let me know. All right.
That's fantastic, Neeraj. Thanks for your time. So it's much appreciable. You covered cutting edge services, which I particularly require from my side. As I said earlier, I'm working on the Dockers and Kubernetes, some other stuffs in my current project. So still in the pilot phase, but this demo, it's really fantastic. So we can go forward with integrated, which are the things which can be useful for in my Azure and Google Cloud. That's about it. So thanks for clarifying most of the queries with the team members and you. That's about it. Thank you so much, guys.
Thank you, Uday. I know it's very early morning for you, and Uday, you're based out of Australia, and I have people, all over the place, the global audience, like people from US. Della, she's based out of US, and we have people from India. So I really appreciate everybody joining in and showing genuine interest in Azure Talk. And as I said, I will continue having these sessions, and objective is very clear, to share knowledge and be the best community. So we have Azure Talk Telegram group. I hope most of you are already part of that. If you're not, please do refer. The link is there to join that group. Go post your questions. I'm 100% sure. I have so many active community members. There's a lot of community heroes who will answer your questions. And without, I have 100% confidence that you will get answers to all of your questions. If you don't, you can budge me on Telegram, or you can drop me a message on LinkedIn, anywhere. So please do feel free to join that group and post your questions, share your knowledge. Not only if you have something to share, please do feel free to share that. I want to say thank you to everybody who joined the call today, and I really appreciate it. Once again, thank you very much for joining Azure Talk call today. We'll have more sessions. Thank you.
Cool, Neeraj. Thank you so much. Cheers.
Thank you, Neeraj.